Hi you guys, welcome back to another video. Jag here. Today we're going to continue on with our Math 11 content. We're going to move on to the operations with rational expressions. And of course, all of these expressions involve factoring. So if that's something that you feel like you're having trouble with, definitely go online. There's so many online resources nowadays, and factoring was basically a topic that was introduced in grade 10. You can see it's going to go into grade 11 and then grade 12 as well, because you're definitely going to be taking these university level grade 12 courses. So definitely the factoring has to be really good. And just go online. You can also watch YouTube videos and stuff on factoring. If you go on my channel, I have a lot of videos covering the different methods of factoring, and that will be something that we'll be reviewing as well. Okay, so with that, let's get started. We're gonna go to example 1 here. All right, so example 1 says simplify and state any restrictions. And let's try the first question. It says a squared plus 2a, right, over 3a times. And we're going to try questions where you actually have to do some factoring. Okay, so 20a squared over 5a squared plus 10a. Okay, also when you're doing the questions, make sure you're always taking your time, okay? Even if you're really good at factoring, you want to take your time as you solve each of these questions. All right, so if you take a look right here, when you're multiplying the rational expressions, you're going to factor each of the numerators and the denominators separately if you're able to. So let's do the first fraction here. It says a squared plus 2a. I'm going to take out the a. I'm left with a plus 2. Okay? And this is, again, you can always FOIL it out. A times a is a squared. A times 2 is 2a. The denominator is 3a. I'm just going to leave that the same because we can't really factor anything with that. All right? And then times, same thing here, 20a squared. This is just one term. I can't factor it, so I'm just going to leave it the same. But look at the denominator right here for the second fraction. 5a squared plus 10a. You're going to take out the greatest common factor. I'm going to take out 5a because I see that they both have a. And they both can be divided by 5. Okay, so you're going to open up the bracket now. From 5a squared, I'm left with a, right? Because there are two a's here. Plus, and you're going to do 10a divided by 5a, which is equal to 2. Okay, and then you're going to close the bracket. So this is what we have so far. And then I'm going to see what I have for the numerator and the denominator, if something can cancel out. I see a plus 2. And also remember, factors have to be at the top and the bottom, okay, for you to cancel it out. I can also cancel out, okay, right here. I see a and a. So I'm going to cross it out, right, like this. Okay, and you want to make sure you're showing all of your steps, okay, as you're writing out your answer. And then what are we left with here? I think you can still write the fraction out. I have 1 over 3 as a denominator times, okay, and then maybe let's cross out stuff here as well. This is 20 divided by 5, which is 4. And for a, this is a squared minus a to the power of 1, which is a to the power of 1. Okay, and then you can multiply it together. This is equal to 4a over 3. Okay, so say like this. And this is actually your final answer, right? And you want to make sure you're stating all of the restrictions. So you're just going to put comma. And the restrictions are coming from what you see in the denominator of the intermediate steps. Do you see how it's a plus 2? So you change the sign. I'm going to write a cannot equal negative 2. Okay, now what's the reason for this? Because if a is negative 2 and you sub it in here, that's negative 2 plus 2, which is 0. So anytime the denominator becomes 0, the entire expression is undefined. Okay, at the same time, I also see a on the bottom by itself, when a is on the bottom by itself, you're going to put a cannot equal to 0. Right? So say this was like 3 times 0. That would be 0. So the whole denominator would also be 0. Again, the entire expression is undefined. Okay, so this is the final answer. And also, sometimes I see students writing restrictions like up here somewhere. No, restrictions have to be at the bottom, right beside your final answer. Okay, and then sometimes students are looking at like this. They're like, oh, this is my final answer. And I don't see any, like I don't see the variable a in the denominator. So they're like, there are no restrictions. But that's not what it means. Okay, you have to remember the restriction is coming from the denominator also of the intermediate steps. And that's the reason that we're factoring out the denominator to see. It actually gives us the restrictions right here. Also, when you're stating the restrictions, you do have to make sure you're stating it from least to greatest, right? So I don't want to write a is less than 0 first. I'm going to write a is less than -2. And then, or I mean, a cannot equal -2. And then a cannot equal to 0. Okay, as many restrictions as you have for the denominators, you want to state all of them here at the bottom. Okay, so this was a really simple example. With that, let's just try one more question. Okay, so here we are. Here's part B of the question, or for example 1. You notice this entire whole fraction is divided by this whole fraction right here. So again, what we're going to do is let's first actually factor, okay, each of the numerators and the denominators here. So this is 2x squared minus 8x. So I'm going to take out 2x, and I'm left with like x minus, because this is negative 8x divided by 2x, right, which is -4. Okay, and I'm going to close the bracket. Make sure as you factor, you're like checking your answers, right, at the same time. This here is a simple trinomial, okay? The product, that's right, P, is -10. Okay, like -10. And the sum is -3. So the sum is always going to be this middle number right here. The product is always the last number because it's a simple trinomial. You're coming up with 2 factors. Maybe let's just write it at the bottom here, right? I can do 5 times 2, right, which is equal to 10. But when you add the numbers, it has to equal to -3. So I'm going to make the 5 negative here. Do you see that? So -5 times 2 is -10. -5 plus 2 is -3. When it's a simple trinomial like this, that means there's no number in front of the x squared. So I can just write the factors out. So I'm going to do x minus 5, x plus 2. Okay, and in this case, when you're factoring the simple trinomials, you don't change the sign. You can just leave it the same, right? Divided by, I'm going to keep the 4x squared the same because we can't do anything with it. But let's take a look at the denominator. Again, a simple trinomial. The product is positive 20, right? And the sum is the middle number, which is -9. So when you're looking for the 2 factors here, I want to just take like, factors of 20. Let's make a line, right? So you can do 5 times 4, I know is 20. When you add both of them together, the numbers has to equal to -9. So in this case, I'm going to make both of these numbers negative. Okay, -5 plus -4 is -9. Oh, and -5 times -4, positive 20. So both of these conditions have to be satisfied, okay, with the factors. So I have -5 and -4, so I'm going to do x minus 5 and x minus 4. Okay, so remember here though, we're basically dividing the rational expression here, right? So I'm going to keep my first fraction the same. This is just like when you're dividing fractions, right? Over x minus 5, x plus 2. So remember when you divide fractions, you're going to change the sign to multiplication. And I'm going to flip over the second fraction. Okay, so it becomes x minus 5 and x minus 4 is on top over 4x squared. Right? Hopefully everyone sees that. And then Because so as soon as you get to the multiplication part, now I can actually cancel out the common factors in the numerator and denominator. I see x minus 5, it's gone. All right here. And can we cancel anything else out? We can cancel out the x here as well, and the 2. So like 2 goes into 2 once, 2 goes into 4. Like 4 divided by 2 is 2. This is 1x, and this is 2x's, right? So we're going to take one of them out, like this. And of course, if you find that a little bit like confusing, okay, you can just like multiply the numerator and denominator, and then you can simplify it out as well. So take a look in the numerator. I have x minus 4 and x minus 4. X minus 4 squared, like this. And in the denominator, what do we have here? All right, we have 2x and then x plus 2. Okay, so yeah, it seems like a little bit like messy maybe, okay, if you can't see that. But I can see that we can just cancel out the factors right away, okay? And that way, you just end up with like the final answer here. All right, we're going to put like a comma. And first, we're going to write down so that we're going to go to this intermediate step right here. Or even like here, right? Or maybe like this one, because you can see we already flipped over the fraction here. So let's take a look at this intermediate step. Okay, we'll start off with x plus 2. And I'm going to change the sign. So x cannot equal negative 2. I see x by itself here, like it's like 2x. So x cannot equal 0. Okay, and the last factor here says x minus 5. You change the sign. Okay, x cannot equal to positive 5. Do you see that? This would be 5 minus 5, which would be 0. X cannot be negative 2. Negative 2 plus 2 is 0. And if x is equal to 0 here, this would just be like, 2 times 0, which is 0. Okay, so basically the restriction is only coming from the denominator of any of these intermediate steps here. So when you're dividing like the rational expressions, okay, the intermediate step, which should be the step right after that, it should be right after you flip over the fraction. The denominators right here, those are the restrictions for your final answer. And again, look how I like stated it. It should be from least to greatest, like the negative number, like negative 2, 0, and then positive 5. Okay, like in this order, right beside your final answer. All right, so hopefully that makes sense. This is actually a really good example. So we did one example for multiplying rational expressions, and the second one was for dividing rational expressions. All right, so that brings this video to an end, but thank you for watching. And if you have any questions or comments, as always, make sure you're putting it in the comment section below. If there are any topics that you want me to cover, you can also put that in the comments and I'll like get back to you right away, or I'll be making videos on that topic regardless. If you are attending a school that has 2 semesters, the first semester should be coming to an end very soon by the end of January. So as you're like, studying for your exams or something and you have any questions, you can just like message in the comments and I'll be checking all the messages periodically. So I'll definitely get back to you. So once again, thanks for watching. Please make sure you like, share, and subscribe to this channel, and I'll see everyone next time. Bye.